In this video, we are going over the concept of thermodynamics. In the previous video, we learned that thermodynamics refers to the heat and energy exchange in a chemical reaction. To this end, we are going to learn the different types of reactions that exist depending on what's happening with the heat in the system. First, on the left side of the slide, we have what is an exothermic reaction. The name implies exothermic. It means that, quote unquote, exo means exit, thermic means heat. So overall, what we see in this type of a reaction is that heat is released from the system. So when we observe this type of reaction, we see that heat is the product of the reaction. In the left side, in the bottom of the slide, we have an example of an exothermic reaction. Here we have solid carbon reacting with hydrogen gas, producing methane gas. Next to the methane, we see a plus sign and we see an 18 kcal symbol. This is actually the units of energy that are produced in the system. Utilizing an energy diagram, we can see as the reaction progresses, what are going to happen overall to the potential energies of the reactants and the products. In an exothermic reaction, the energy of the reactants is going to be higher compared to the energy of the products. So what we see overall is that if we are actually plotting the energy of the reactants versus the energy of the products, we see that difference in the position in the curve. Moreover, when it comes to the illustration, we can even look at the activation energy that is present in the reaction. If the reaction, or if a reaction in chemistry does not release heat, well, then it could absorb heat. In a reaction that absorbs heat is known as an endothermic reaction. And as I just mentioned, this reaction, heat is absorbed, and we know that it is absorbed because the heat is going to be in the reactant side of your chemical reaction. So here we have an example of an endothermic reaction where we have nitrogen gas reacting with oxygen gas. Then we need to see here the heat that it is required to be absorbed from the system in order to make specifically nitrogen monoxide. When we look overall at the energy diagram for an endothermic reaction, one of the things that we can notice is that the energy of the reactants is actually lower compared to the energy of the products. And overall, now we're going to proceed to look at an example of thermodynamics. We are going to look specifically at calorimetry as an example of the thermodynamics of a system. Calorimetry, by definition, looks at the heat of the reaction. These reactions can, as we just observed, absorb heat or release heat. So in calorimetry, this is what we do. If we're trying to investigate calorimetry, we actually have an instrument to look at calorimetry, and it is known as a calorimeter. This calorimeter is actually used to measure heat transfer within a system. And in this example, we're specifically going to look at combustion. In a combustion reaction, specifically, we can look at how, in this example, we have a calorimeter system where we are going to place a food sample inside of the calorimeter, And overall, we can observe how much energy is released from that food sample. This is important because these experiments are what is performed in order to understand what is the energy that is released in food samples. And when this happens, this is illustrated in nutrition labels, which those are readily available in many food samples that we have nowadays. So how does the calorimeter work in order for looking at this combustion reaction of a food sample in order to understand the energy that is stored? Well, when it comes to this calorimeter, we are going to have a chamber that is made out of steel that is known as the steel combustion chamber. In this chamber, a food sample is placed. And because there is the presence of oxygen, one of the things that's going to happen is that this food sample is going to undergo a combustion reaction. So if I write the chemical reaction that is happening overall at this calorimeter, what's happening is that that food sample is going to be reacting with oxygen gas. Since the food sample is going to have compounds that have carbon, hydrogens, and oxygens, in this combustion reaction, we are going to make carbon dioxide, we're going to make water, and in addition, we're going to produce heat. So the combustion reaction that happens here is an exothermic process. We can observe that this heat is illustrated here by the flame that we observe here. When that heat is released, let's understand that that heat that is released, that I'm just drawing some squiggly lines from the steel combustion chamber into the water, it's actually going to be measured by utilizing a thermometer. Since this thermometer can detect what is the temperature of the water before the combustion and after the combustion, all this information is gathered, and through mathematical equations, we can actually calculate how much energy is stored in a food sample by looking at the heat transfer that is going to happen from the food sample into the water. As I just mentioned, when it comes to this type of experiment in calorimetry, this has been very useful in order for us to obtain nutrition facts labels. And a nutrition facts label is going to tell you what is the energy that is stored in a particular food sample depending on its serving size. When it comes to food labels, understand that when it comes to the energy that is expressed, it is actually shown as nutritional calorie. And nutritional calorie has a capital C. Now, the units of energy that I showed in the previous slide were mentioned in kilocalorie as a unit of energy. So what is the relationship between nutritional calories and kilocalories? They're actually 1-to-1. So 1 nutritional calorie equals 1 kilocalorie. Now, it has been already shown experimentally that there are typical values of energy specifically into 3 different biomolecules that are the only ones that the body utilizes in order to create chemical energy inside of the body. Those biomolecules are carbohydrate, fat, and protein. So when we look at a nutrition facts label, even though all kinds of information is given, and as you can see, the example that we have here is illustrating the nutrition facts label for crackers. And even though we have the fat, the saturated fat, the trans fat, polyunsaturated, we got the cholesterol, we got the sodium, we have the fiber, and so on and so forth. The only thing that it is utilized in order to calculate the value that you see here of 120 calories is the amount of overall fat, overall carbohydrates, and lastly, overall protein. So let's actually perform the calculation and prove to ourselves that specifically this food label has stored in this serving 120 nutritional calories. So what you do overall is that you make a list of the different biomolecules. The way that it is listed, first we have fat. Next, you have carbohydrates. Lastly, we have protein. So the first thing that we do is that we write down the amounts that we have for them in the food label. So we have 4 grams of fat. We have 19 grams of carbohydrate. And lastly, we have 2 grams of protein. Next, we are going to look at the typical energy values for the 3 food types that actually generate energy when it is placed in the body. For fat, we can observe that every gram of fat is going to correspond to 9 kilocalories of energy in that food. So when we do this, we are going to multiply this by 9 kilocalories, or in other words, 9 nutritional calories, because per gram, that's how much is contributed. So when we take these two numbers, this is going to be 36 kilocalories, or nutritional calories, is what the fat is contributing. Let's move to the carbohydrates. When it comes to the carbohydrates, let's understand that each carbohydrate is going to produce 4 kilocalories per gram of energy. So we are going to do 4 kilocalories per gram of the substance. So when we take 19 times 4, we see that there's 76 kilocalories that are actually produced by the carbohydrate. Lastly, we have the protein. Per gram of protein, this corresponds to 4 nutritional calories, or in other words, 4 kilocalories. So when we multiply 2 times 4, there's 8 kilocalories that are produced by the protein. Now, after we have this information, we can see that in this food item, the biomolecule that actually produces the most energy is the carbohydrate, because we see that there's 76 kilocalories of energy that are produced. Lastly, if we add overall 36, 76, and 8, that's where the 120 kilocalories per serving in the food label comes from. Let me highlight it. So this 120 is the 120 that is here. Whenever we look at food labels, sometimes we can observe that there's all information in the design of the food. But it is very important that we look closely at the nutrition facts label that is available to us. So for example, here we have Nature Valley protein chewy bars. Let's actually do an exercise in which we analyze what the food label specifically for this food. The first thing that we need to look at is what is the serving size in grams? And if you're curious about that, we can see specifically that that is given right here. So this food item on average is going to be 40 grams. Next, if we're trying to determine how many calories are in one serving, we can do a similar calculation what we did before. So for this food item, we have, in terms of the fat, the carbohydrate, I'm going to shorthand it by putting carbs. Lastly, we have the protein. Next, we are going to write specifically how much we have in the food. So this has 12 grams of fat. This has 14 grams of carbohydrate, and it has 10 grams of protein. Per gram of fat, 9 kilocalories of energy are produced. For carbs, 4 kilocalories are produced. And lastly, for protein is 4 kilocalories. So when I do this math, 12 times 9, that means that the fat is going to contribute 108 kilocalories. For the carbs, 14 times 4, this is going to be 56 kilocalories. And lastly, we have the protein, which this is 40 kilocalories. So when we look overall at this food item, and we're trying to determine what is the major source of calories in this food item, let's understand that by looking at the numbers of fat, carbs, and proteins, we can determine specifically that the major source of the nutritional calories in this food item is going to be the fat, because it has the highest number of nutritional calories when we investigate the contributions of fats, carbohydrates, and protein.